Hello and welcome to today's engineering topic. I'm Steve Ruffin of Design and Process, and we're a SOLIDWORKS authorized reseller located here near Pensacola, Florida. So today we're going to talk about SOLIDWORKS Model Mania 2023. And in case you're unaware of what SOLIDWORKS Model Mania is, it was first introduced in 2000. It was set up to showcase SOLIDWORKS 3D CAD software's new features, help users improve their methodologies, and learn how to utilize the software more completely. So Model Mania has turned out to be a huge success, and it's been running for 23 years straight, even through COVID. So we're going to create a series of additional videos, one for each Model Mania, starting with Model Mania 2000 and progressing forward. So if you like this video, push the like button and subscribe to our channel, and you'll be notified when we post the additional videos. So, like in years past, this year's Model Mania was an interesting one. When you compete in Model Mania each year, they provide a Phase 1 document, as you can see here. And once you've completed that Phase 1 model, they give you the Phase 2 document. Now, the Phase 2 document provides real-world engineering changes, and these changes will quickly determine if your original model is robust and easily modified. It will be a humbling experience, even if you don't think it will be. So I'm not going to show you the Phase 2 document at all in this video, but you can download it from our website at the link below. And today, some of the methods I used during my Phase 1 model were not easily modifiable. So I'll show you the shenanigans I had to do to accomplish the engineering changes in the Phase 2 document. I'll then show you how the Model Mania author, Jen Dirksen, a good friend of mine, created this geometry and made the subsequent changes. Her methods make it a lot faster to model and modify than my approach. So even a 25-year veteran of SOLIDWORKS can continually improve. Now, I'm going to say, if you really want to test yourself, I'd recommend you pause the video before we get into SOLIDWORKS and get the PDF document from the link below. Create the model yourself from the Phase 1 document, and try not to look at the second page, and then come back to this video, see how I did it, and then return and try to make the engineering changes to your models to see how well you did and how robust your modeling was. It may turn out to have been way better, and if it is, make us a quick video and send it to us, or give us some instructions. We love to pass on that kind of information. That's what Model Mania is all about. So without further ado, let's get started and see how I approached Model Mania 2023. Okay, so here we are in SOLIDWORKS. We're just gonna start a new part, millimeter. Come here and just put a circle here on the top plane. Since it's one of our largest pieces of geometry, we'll dimension that. 50. And we'll come up here and do an extrude. Mid-plane 30. Okay. And then we've got a section here at the bottom that's tangent to the bottom, so let's go ahead and just make a tangent piece down here, and that way we can draw our profile on here. So we'll just draw a rectangle on here. We made it vertical to the center point there. Throw our largest dimension on here. Again, we're kind of moving from our biggest things to our smallest things. And then we're going to throw a little line in here because they've got a cut in here, and it's a little strange to try to do that cut separately, I think. So we'll make both of these equal, and that will make this thing symmetric. Throw our 30 dimension on here, and let's throw our 14 dimension on here. Okay, and let's extrude this. 15 millimeters in one direction. Go that way. 15. Okay, all right, got that. So now let's put our full round here on this end. And I like to do this full round out here just because it's easier to see later. Your future self will be happier that you did that. And it also ensures that geometry-wise it always stays with what you intended. Alright, so now we've picked on the front plane here, and we're just gonna draw, I don't know, like a tombstone kind of thing out here. Go back over that, get my arc line. If you've taken an Essentials class, you know how to do that. And then we'll pick this line in the origin. We'll do a midpoint constraint. Let's put a dimension on this radius, which is 12.5. And then the overall dimension that they give us is 108. Okay, and then let's extrude that. And midplane, and I think the width here is 30, so let's make that 30. And then I like to just repeat, just start with your largest cuts next, right? So start with your largest extrudes first, then move on to your largest cuts, and work your way down in size. And this always makes your future self happier. And pick on the top plane here, and let's just throw a rectangle on here. This is nice and fast. I like this method. At least I thought I did. You'll see why in a minute. And we'll pick midpoint here. I love the midpoint constraint because there's lots of symmetry in things, and so you use that a lot once you know how to do that. And that's 2 millimeters across. So for our clamp here, and we just need to extrude cut this through both directions. Okay. And then next, hole wise, let's come in here and put in our anti-metric socket head cap screw. I believe it's an M6. Alright, we pick this plane and wake up our center point here. Hit enter again, and it pulls our hole command back up, just kind of like you're used to if you ever used AutoCAD. Pick our positions again, hit that, and pick wake up that point and hit the concentric. All right. So I think the next thing we have here is the hexagon to hold the nut in place. So let's come in here and put this in. And I believe this is 11 across. So let's put a dimension in here, 11. And in the drawing they show this as horizontal, so we'll do the same. And we'll extrude cut, and this will be blind, 6 millimeters. Tell it okay. All right, then our next thing is to put in our fillets. And I always tell people to start with your largest fillets first. I believe these are 2 millimeters. And then work your way down. You always end up with a better result, and you're less likely to get yourself in a trap where you've picked one radius before you should have picked another one. And we'll just pick this one out here and this one out here. So I see this happen a lot during classes. People will pick on something and they'll freak out, and then they'll hit escape and it takes everything out. Just go back there and re-click the part that made all your fillet preview go away, and then just continue on with your fillets. So that way, and don't just hit enter and make another fillet, because your future self will hate you for that. So let's throw a fillet on here and here. We're doing the inside fillets now. Grab that. You can see our tangent propagation has allowed us to go all the way around those. Okay, and again, if we try to do this out here, it's bad. So just re-click it and get out of that. We'll just do it as a separate fillet. All right, so we'll hit the enter key and did the fillet command again. Pick those two edges. I think we're pretty good here. Now let's change our material properties to plain carbon steel, because that's what the drawing calls out. on evaluate, and this is supposed to be 337.97, and woohoo, there we are, we're 337.97. So that's phase 1. So if you downloaded the PDF, you can see that on our second page, we've got several changes that need to be made. And so let's go in here and roll back here. It says that this section here needs to be 45 degrees off, so that's a pretty big change. So let's do that one first. We'll come in here, and instead of being parallel, let's change this to 45 degrees, and looks like we're gonna have to flip this, not there, let's flip that here. Okay, that looks good. And then let's pull this down, and uh-oh. Well, that's not great. Okay. So let's go in here and look at our sketch and see what we can do here. Oh, yeah, okay. See, so this may not have been the best way to have approached this model based on this. If there was some way to flip your horizontals and verticals really quickly, that would be nice. So let's come back in here and let's do Control Z, get that plane back like it was. And let's kind of do a rebuild here real quick. It looks like we still have a little issue here, so I guess when it reconstructed that, something weird was going on here. Looks like we've got some redundancy here between that and that, so since they're collinear and equal, I guess we don't need that. So, alright, let's get back out of our sketch. So now we're back to where we were. So we're back to phase 1, yay. Alright, so let's look at what this thing is made out of, because maybe we can move it 45 degrees, right? So what difference, you know, Hakuna Matata, one way or the other, it doesn't matter. And so what we'll need to do here is wake up our temporary axes so that we can put a plane that's 45 degrees off of the center and off the front plane. And actually, we'll probably have to do 135, which will be the opposite angle there. So let's do that. Yeah, okay. And we'll tell it okay. Let's pull this down so that we get our tab here. Okay, well that's not changed yet, so we need to come in here and change our plane, our sketch plane for that tab. And we'll come down here and pick the new plane that we just made back in time, so we went back in time. We'll tell it okay, and it's giving us a little error here, so let's see what we can figure out what's going on. And okay, so I guess that edge really isn't there anymore, so let's just get rid of that dimension. And in the change document, it still shows it as a reference dimension, but it shows this as 42.5. So okay, all right. So we'll turn that reference dimension into a driving dimension. All right. So let's put shoot. Okay. Let's see. We've got to fix this now. All right. So let's come back in here, and looks like we've got a horizontal constraint here. So horizontal and vertical seems to have hurt us a little bit on there, so we'll delete that. Let's go look at our other dimensions. Let's just get rid of all the verticals and horizontals in our sketch. And let me get out of that. And I like to just yank on the geometry. I tell people in my classes all the time, yank on your geometry. I made that line perpendicular to that, but okay. So let's make this line parallel and equal. Okay. So now we're all back in black, just like the song says. And let's get out of that. And let's. It looks like everything's done there. Okay. And we need to change this dimension to 73. Rebuild that. Or you can press Control B either way. And last but not least, I think this socket head is supposed to now be a slot. And this is kind of cool. I don't think a lot of people realize this unless they've taken some of our advanced classes. But you can turn that into, you can turn that countersunk hole into a countersunk slot. Now, the problem we have here is that it utilized the center of that, so we need to delete that out and then grab this end point and make it coincident, or concentric, with the outer arc there. And you can see we can kind of still move it, but based on the way things have worked so far, let's maybe make it parallel to that as opposed to horizontal or vertical, because who knows what happens in phase 3 or revision 3, right? So we should probably have learned our lesson there. Let's get rid of our temporary axes there. And let's go to evaluate and see how we did. This is supposed to be 356.27, and that's close enough. 356.27 to me. Now let's go look at how the author of SOLIDWORKS Model Mania 2023 did this. My good friend Jen Dirksen there at SOLIDWORKS. She's amazing, and I learned a lot from looking at this model. So she started out very similar to the way we did. And again, 50, mid-plane. Mid-plane is your friend on your very first feature every time. There's no doubt about that. And this is 30 again. Alright, so we've got that. So let's start here on our top plane. And she uses an interesting technique here. I really like this. And I'm going to start using this myself more often now that I see it and see how powerful it is. So she's going to use a thin extrude here. And what she does here, well, I guess we need to put a tangency constraint on here so that it stays horizontal and tangent to that circle, right? And so she throws just the one dimension on here, and then she comes in and uses a thin extrude. Now this is really kind of cosmic. I like it. And rather than just doing a blind, your future self will love you better if you set this to through all, and that way if the center dimension changes, it does that, and then it's 15 millimeters that way. But you see, that's just that one feature, and we've done it. And let's put the fillet on here, the full round fillet on here. All right, and then this was also interesting. So put the cut in separately, which honestly that usually is the better practice, rather than what I did by putting it all into one sketch, because it's easier for you to see your cuts and come back and repair them more easily. So that's up to you. That's up to how your standards are. But this is also interesting. So do a cut extrude up to surface, and it interpolates that surface as that entire cylinder. And so it gives us the same cut that we did in my example. So here we're going to put the tab back on here. We'll just use the same methodology that I used. Come back over here and get our arc, bring it down, straight up, and we'll just make this midpoint, and throw a dimension on here, 12.5, overall dimension 108. Okay, and then we need to extrude this tab, mid-plane 30, looks good. Alright, and then very similar, to the way we did it. We starts with our bigger cuts first, and put a dimension on here, 42, cut through all. And in this next part, she does an interesting thing. She utilizes the same technique that she used on that bottom tangent portion in it. So it's, you just draw a single line from the center out to the outside edge, right? And then we use a thin extruded cut feature through all both directions and mid-plane and 2 millimeters. So, what? Look at that. That's super fast. It's one line, right? That's amazing. the holes we've got to kind of do the same way. There's no real way around what we did there. Let's come in here and put the hole in, pick our positions, pick this plane, wake up the center point, put that in, the enter key, the enter key again, go to positions, wake up the center point again. Okay, so almost done with this. Gotta put the hex on here. And you know, there's multiple ways to dimension this, but you know, you can dimension it just off of the circle, the construction circle. That works also, correct? And then just make that horizontal like we did in the previous version. And extruded cut, blind, 6mm. And then we've got to put our fillets on here. So we'll do the same thing again. Like that, and they're all 2mm. It's called out in the drawing. And pick all the largest ones first. And you know, I would definitely just play around with this, but I've always found that this methodology works better if you pick the largest ones first and then work your way down to the smaller ones, and then work your way down to the interior ones. And because of the tangent propagation, this gets us all the way around both of those parts again. Okay, so put the fillet on both those edges. There's no shame in zooming. Tell it okay. And I think we're good there. So let's change the material property to plain carbon steel and evaluate. And ta-da! All right, so she's got it done, and I would say that's a little quicker. But here's where things make a difference. So we go to phase 2 and we get ready to make our changes. So in her case, it's a lot simpler because all she's got to do is come in here, get rid of that one horizontal constraint instead of the 50 that we had because of the way we did it. Move that line around, maybe throw some construction geometry in here, a midpoint, center line, just so it'll be something good to dimension against. Throw a 45-degree dimension on here between that and there. Okay, and then let's modify this. This is 73 now. And get out of that sketch. And oh, something weird did happen here. So not everyone's immune. So let's see what happens here. This is the maybe Let's go edit this. Okay, because that edge really isn't there anymore. So in the update document, it shows this as 42.5. It has a reference dimension there on both documents, but we'll use this now as a driving dimension, since obviously that tab needs to stay the same. Okay, and wow. So I think all we need to do now is just modify that to a slot. Same process here, really. Come back in here, move our dimension up and out of the way, get rid of that coincident constraint, and then put a concentric constraint between the center and that. And I guess we can put the parallel constraint on there again. And exit. There it goes. And let's look at our mass properties. And again, there we are. So a much faster methodology, a really cool ways of doing that, and it's really impressive. And I hope you gained something from this tutorial in the Model Mania 2023. Look for all of the new videos coming up, and we appreciate your time. But if you have any questions, feel free to put your comments down below or put comments on our website, and we'll do our best to answer them and help you out. We appreciate it and look forward to seeing you again. Thanks. Bye.